Welcome to another theatre time, and it's the end of our story of dimming, you'll be pleased to hear. We left off with the Thyristor valve, which is kind of like something that size, and it's now been replaced with something about that size. Dimmers have got smaller, dimmers have got lighter, dimmers have got portable, we've got full remote control. At last, we have arrived in the modern era. He says, suddenly looking and thinking, someone's nicked my crib sheet. There it is. Right, so Thyristors. Thyristor is an interesting name actually. It comes from a combination of a thyrotron and transistor. And the Thyristor construction is sort of there. It's P and N type materials. If you want to know about it, go and look it up. This is the bit that you might want. I don't know. It's P and N type materials. There's a gate on the P section nearest the cathode. When you pulse that, the thing conducts, and it's monodirectional. It conducts, cathode to anode. That's it. That's the electron flow. It doesn't go the other way. But we'll get around that in a minute. What else is there to say about that? Not a lot. That's how they schematically drawn inside. The thing is with the Thyristor, like the Thyrotron, you turn it on, it stays on until the current through it drops to 0. So if you use one, you'll only get half wave on the on your output. So we'll stop this rubbish now and we'll look at some pictures and some other things, do some drawings and whatever, and get a better idea of how they work, how we use them, and what fun can be had with them. Okay, so what have we got here? We've got what appears to be a diode. It's not, because it's got a thing there, it's got a gate there. When we put pulse on that gate, this thing conducts, and it stays conducting until the current through it passes to 0. I'm not going to do the AC waveform again because the drawings are pathetic. The advantage with this is that it's very efficient. There's virtually no heat losses in it. There's no heated cathodes, none of that nonsense. It's just a three-pronged device. Anode, cathode, gate. Is that even in focus? Anode, stud, cathode, gate. They come in various packages. They like transistors and MOSFETs and whatever else, but high energy ones tend to be stud mounted, bolt them direct to the heatsink. Brilliant. That's fine, but with that we've only got sort of nothing through there. We've only got control on the half cycle. How do we get around that? Easy. Another one there, slightly smaller this time. And there's its gate, and the other way we put another. And this is exactly what they did. They're back to back. It's exactly what they did with the Thyrotrons as well. And then you can link those two. It doesn't matter, it's a dead pulse, it's wasted spark type ignition system, really. That's it. It's that simple. We've now got full wave, and we can chop up the waveform whichever way we go. We've got lighting control. We've got lighting control that is now carryable. Having said that, the old Tempest racks that I started on was still 17 kilos, and carrying 2 of those in each hand was not funny, but it was a darn sight easier than the Junior 8 right back in the Resistance video. There's a way around this. We now have this weird thing, which I find very difficult to draw. Fill that in black. There we go. Called a triac. This is a bidirectional Thyristor. It's 2 of these. It's these 2 in one package. So we're now getting really small. When we were at college, these were just coming out. We were worried about them. Anyway, that's how you get round the the full wave bit. You don't need to rectify it, although they tend to in your domestic wall dimmers, but certainly here you don't. Get rid of that. Here we go. Here's one with a triac in it. This, if I can get it out. How did I get it into its package? Okay, it went into its package. It must come out. Pause. Too late. This is a heatsink. This is commercially available on eBay. This claims to be a 2 kilowatt power controller using a triac. And it's very simple. There's the control potentiometer there. There's a potentiometer there for setting its preset. It's 2 capacitors and 2 resistors. There's a different package. That's a triac in a different package to the stud mount, and a small heatsink. Would I run this at 2 kilowatt? Not continuously, no. It's a very, very small heatsink. And the tracks, you want to pull 10 amps through these? I don't think so. But it does show you how small they are. This was £1.65 including postage I paid for this one. It's not brilliant. It doesn't go down to 0. It goes down to about 25%. And in there, which you can't see, is a thing called a diac. We get a bit of paper back. I'll get a bit of paper back. A diac is a triac without the gate. Thing with the diac is it doesn't turn on. They don't turn on until they get a certain potential across them. Once they get a certain number of volts across them, they'll let go and they'll conduct. And by controlling the rise of the potential across the diac, you can control whereabouts in the phase it triggers. It's a phase shift type device. In fact, the whole dimmer is. So when you get to a certain point in the phase, this one uses a resistor capacitive network to charge the diac. Okay, we'll do it that way. There we are. Just do a W. That's the easiest way. Diac there. The charging of the capacitors controlled by the resistor. When it gets to a certain point, that conducts, pulses the gate on the triac, and if you've got, there's your AC waveform. So we're not going to do that. There's your see, we only need half of it, and the diac lets go at about there, so we get that portion coming through, just down to 0. It effectively alters the RMS value of the voltage coming out, which therefore controls the amount of current. Very clever, very simple. It took a long time to come about. When did we first start getting? The first Thyristor devices were released commercially in 1956. They started to make their way into theatre control, I think, in the late 60s. They were incredibly expensive. I'm going to change the camera again. I'm going to tell you the story. The story from an ex-engineer of Stranda, who I'm not going to name because he might still be alive. I'm not going to impersonate him because I can't afford the huge number of cigarettes he used to smoke. Three at one time in a lecture. If he sees this, he'll know who he is. Brilliant guy. He worked with Strand for about 30 odd years in R&D. And every Christmas had this Christmas party. And the R&D department was supposed to come along and show this great device, whatever it was, their latest wonderful discovery, invention, whatever. And they turned up with this little box and a 2K lantern or something and plugged it all in. Look, we can take this little thin bit of wire over it and we can do this. And the light goes up and down. So, oh, that's wonderful. What is it? it's a Thyristor. Well, it's two Thyristors. It's two Thyristors back to back. These little, you know, they got one out and showed it to them wherever it's gone. You know, these couple of these doing the work. Oh, wow, isn't that wonderful? Blah, 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 blah. Isn't that great? Can't we use it? Well, it's not going to catch on. Why not? They're £400 each. That was in the 60s. Fortunately, like everything electronic, the price has come down, and it's come down massively since those days. And thyristors are used, and triacs are used in just about everything now. The largest I've seen was bolted to a heatsink that took up the entire power unit of an electric train. I think it was at Dagenham. We could actually see through the grills on the side of the train. You see this massive nut with a big thick wire coming out of it. And we saw another one in a shop window in Edgware Road. Literally, it was sort of like that size, with a cable like that sticking out of it, and a little thin wire for the gate. And they were the power controllers for the electric trains on whichever section of line that was going through Essex. And they could control about 3,000 amps. Which is probably, you'd need an awfully big Thyrotron. And let's not even think about saturable reactors or resistances or any of that stuff. It's absolutely incredible. And that is where we're at now. These things are beautifully controlled. The basic dimmer now can, with its added electronics and its own brain, can send all sorts of information back to the control desk. So we all know exactly what's going on all the time. And if it wasn't for that simple little device, lighting wouldn't be where it is today. I think next we better start looking at control. Which probably means going back to resistances, but yeah, we'll look at control. Bye.